Thank you for joining another GraphGeeks talk. Today we have Paco Nathan, who's, I would say, a thought leader in AI, data science, graphs, humans, all things solutions there. Also known as the evil mad scientist for some of you that may know that. So thanks for joining.
Thank you so much, Amy, and welcome everybody. Really appreciate the opportunity to present. And just to give some background, Amy and I had been talking along with some other colleagues of ours about some of the thornier issues that projects struggle with, contend with, especially getting started working with graph technologies. And we were discussing about current trends, what's going on, what we're hearing from different vendors, different practitioners. And that's where I guess the gist of this talk, if I recall, that's what this came out of. The other thing I wanted to present was just, if you've ever watched like PBS or I think there's others on cable TV now, but or streaming, I should say, there's sort of like great lectures in history. I was looking at some recent talks and articles across the industry related to working with graphs and graph technologies, and also just kind of a broader question of like, how does this fit downstream into AI applications, etc. I noticed, wow, there were some really good speakers, really amazing material, and frankly, a lot of it kind of weaves into what I was going to present. So what I've got here, we'll talk about this part about working large scale and also how to think about it. But then I also want to point to great talks. Here's kind of a survey of, some people you should listen to. And I'll be quoting from Dave McCone, Zhamak Dehghani, and Tony Seal, and a lot of other people, just trying to highlight some real gems if you haven't seen them already. But it's basically homework. So, that's the required reading. And then the exercise is a list of really the graph and closely related graph conferences from now through, I guess, October, November, basically the end of the year. It's kind of a survey of like a lot of the major knowledge graph conferences where you can go and compare notes with other people. And I really wanted to recommend this, and I wanted to talk about each one of these conferences and why I'm involved, why I go there, but really, what I take away from it too, because I think at the end of the day, it's a lot about the hallway track and what you can learn from other people who are practitioners, what they're doing, what they're not doing. And so as we come into conference season, which effectively starts end of April, and gosh, we're there. I guess one of my first conferences of the year is going to be on Monday, and then from there, it'll be kind of booked solid until mid-June. As we come into the conference season, the first part of the year, the spring of the year, I want to give an idea of like, what are the ones you should really be checking out? So 3 parts, we'll have some resources and hopefully a lot of Q&A. There's a little bit of overview of who I am, where I've come from. It's been a long and twisty path through dark mazes. But basically, I do have a lot of background working in machine learning and natural language. I got involved in neural networks a long time ago, got involved in what would later be known as cloud. And that all led me to a little team, which would later be known as Databricks. These days, I am at Sensing, and I work in entity resolution in the knowledge graph practice. And as we are working with large customers on knowledge graph practices in production, some very, very, very large use cases, and also very mission critical use cases, like 60% of what we do runs in air gap environments. As I'm interacting more and more with these kinds of customers and finding out what do they do, how do they thread the needle, I wanted to try to share some perspectives on that. So, practical solutions for large data sets, advanced ETL techniques that won't leave you in cycles. I loved all of the graph callback references that Amy had in the bullet list notes for the show. I'm going to start out with one thing which I think is the most crucial that I've heard from teams over and over, at least the teams that are doing well. And the thing is, you don't need to start with a database. And this may sound relatively simplistic or trivial, but when you are actually in a meeting with a whole bunch of folks in enterprise and the architects and the ops people and the people funding it and the security people and all the rest, the one thing that trips up every team that I've ever seen is they start too early with a database. So let's give you a little bit of perspective. Once upon a time, people thought long and hard about data and how to handle it in smart ways. And if you've read the history, there was a team led by Ted Codd at IBM back in the 70s, 60s, and 70s. They really had some breakthroughs. If you want a snapshot from that time, Jenna Jordan has been leading a book club. William Kent was one of the engineers on Ted Codd's team at IBM in San Jose, and he wrote a book in 1978. He went through 2-3 revisions, but it's called Data and, sorry, Jenna's book club has it there. It's a survey through the kind of thinking that they were going through at the time when they had hierarchical databases, network databases. It was pre-SQL. They were trying to understand from a very balkanized view of data and all kinds of weird mainframes. How could they try to have more of a lingua franca? How could they try and piece this together? And Ted Codd, of course, came out with the very famous paper, which led to relational technology for data management. IBM at the time actually used to work for somebody who was an executive in the room at the time when some of these big decisions were made. And I've heard privately what was said, but basically the long and short is IBM ran user studies. They knew that they had graph database technology. Frankly, if you have a hierarchical database and you have parent-child relationships, which is what IMS was doing back in those days to solve some of the nastier problems, you have a graph database. And they knew that there was also, Codicil and other network databases going on. They had products that would be graph databases, and they were thinking about having that as a general pattern for data management. They ran user studies. They found out that really to manipulate this class of graph databases, it would require relatively smart engineers, what they would call A students at IBM, not my language, theirs. And what that translated to was not enough breadth for marketplace. So they made a decision to pivot to a strategy where data management had more guardrails. That is to say, you could hire people who weren't quite as expert, and they would not shoot themselves in the foot. And in the IBM thinking, that meant customers could have larger teams be hired, which would mean a lot more profit. And so we have that now. It's called SQL. The seed idea was, if you go back and read the papers, establish a kind of lingua franca for all data management and abstractions that would apply everywhere. You could take your data and move it from one place to another. It would be glorious. Everybody would be on the same page. Nirvana would be achieved. Actually, the opposite of that happened, because the moment that you got really large relational data systems, then you had data gravity and you had a lot of vendor lock-in, and sort of the whole notion of data independence was thrown out the window. But if you want to read a snapshot from that time, Eric Brewer, who used to teach at Berkeley and did some pretty amazing things at Google, Brewer has a copy of the paper from his class from a decade ago. But the original relational system at IBM was called System R. The source code for that was acquired by a little company that changed its name later to Oracle. And like I said, I knew somebody who was in the room at the time. So here's some history. And this is where people were trying to struggle with ideas. If you go back to the book Data and Reality from William Kent, which is the top link, Jenna Jordan's book club, you'll find that William Kent is going through a lot of issues that we're struggling with today. In fact, William Kent was talking about all these thorny problems with managing data, and he asked the question, do we need to have a semantic layer to try to organize what we understand about our data in terms of graphs? That was in 1978, and look where we are now. So SQL, yeah, it's a great approach if you're building a web app and you need to handle transactions and ACID compliance and be doing your joins and your queries, blah, blah, blah. When you're building graphs from multiple data sources, particularly for data analytics use cases downstream, particularly these days we hear about a lot of use for GraphRag and agentic workflows, etc. When you're doing that, SQL is not really a good approach for reasons that I will describe. And it largely goes back to the fact that people like Ted Codd and William Kent and others, they had some great ideas, and they really mapped out an amazing future for data management. And IBM turned around and said, thank you very much, but we're going to nix. If you could just move your desk back a little bit, and oh, there's my red stapler. Basically, IBM came in and just tore the thing apart and came up with SQL. And Ted Codd spent the rest of his career analyzing and documenting why SQL was such a bad idea. So if you want to understand some of the tensions, it really goes back to those decisions back in the 70s. But the long and short is now, a generation or more has grown up in computing. thinking that any work with data means you're working in SQL. And SQL, I mean, really, it was introduced in the late 70s and 80s. It didn't really get rolling until like the 90s. And frankly, by the time you get into the early aughts, there were a lot of reasons to move away from SQL. And this is where things like Hadoop and then Spark and others came out. So I look at it and it's become this dominant thing. In reality, out in the world, the most popular database is IMS. And, when you're running credit cards, taxes, all kinds of government agencies, all that, those are running on IMS systems. The reason is they work. They run on MVS sysplexes, which have, more than 40-year mean time between failure. So when you're processing for banks or for insurance or for other things that are mission critical applications, they run on these systems. They've been running on these systems for decades. Nobody in their right mind is going to replace them because they just frankly work. What that means, though, is not a lot of people get hands-on. And in fact, at one point in my career, I had to go to Russia. I was sent to Russia to go find developers for IMS because there were so few in the US. So SQL is not the only thing in the world, but a lot of people believe that. And one of the problems that I run into that I find over and over again with teams when they're first approaching work with Graph is the first thing that happens is the software engineers in the room ask, which graph database do we need to use? And they start carving off time to argue and discuss which graph database they're going to select before they even understand the use case. And the idea there is to work with data first, you put it into a database. That idea, that notion comes from understanding the world through a SQL lens. And that's where so many teams get tripped up when they really want to do something with graphs at scale. And I can tell you, the people who really do work all day, every day in production in mission critical apps with graphs do not think this way. And so if you want to get into that league, drop the SQL lens. Databases are useful, but the big data era, Hadoop, Spark, et cetera, demonstrated that databases sometimes pose serious bottlenecks, and they may be what is encumbering a product or an entire company. I've definitely seen plenty of that. And when you look at what's going on, what's happened over the past decade plus with Spark and BigQuery at Google and Snowflake and others, these aren't databases per se. They're sort of database. There are a lot of relational technology deconstructed and then put into distributed systems so that you can be offering platforms that overcome the bottlenecks. And they do provide really good ways to connect multiple data sources together at scale. So one of the things that I'm going to introduce here is this idea you can work with things that are not exactly databases, get your data into shape, get it connected, and begin to be able to pull some structure out of it. Basically taking some subsets, some views from what you've connected together. And from that point, then there are other tools that come into play a long time before it lands into a database, a graph database per se. That is one of the key aspects of being able to handle scale.
Yeah. So quick question or comment on that. I know you're going to talk a little bit later about what Mike Dillinger is doing, but his phrase shift left, shift up, I think is very pertinent right here and in this idea of how much processing can we do ahead of time and reducing either the problem set or refining the data before we get in here. I don't know if you want to explain that shift left comment, but I just feels like it fits really well here.
Thank you. Yeah, no, really. Yeah, and I was going to reference Mike, absolutely. So Mike Dillinger, linguist, went into eBay, helped build out their graph practice, and then spent years at LinkedIn building out their graph practice, more from the understanding of what are we going to do perspective and the governance of it, less so from the nuts and bolts of, oh gosh, here's a graph query. So yeah, Mike's point there was when you are at the scale of LinkedIn, when you're handling graphs that are so big that even to describe the metadata, they could no longer use Microsoft Excel. It was too large. They had to use Google Sheets instead. You have this enormous graph, billions of elements, but more critically, a lot of the structure, the real parts that you have to manipulate, they are measured in hundreds of millions of things where, most teams might only be measuring classes on the order of hundreds or thousands.
Mhm.
LinkedIn is dealing with hundreds of millions. And so contending with that, Mike's point, we just did an interview recently, and I'll link to it later. My point was you really need to understand the structure of your graph, as in the thing that's going to get you tripped up is if you take a very ad hoc approach to what kind of relations you have in the graph. If, for instance, you just go and use some automated tool that automatically builds your graph out of a bunch of unstructured data and comes up with whatever links happen to be
Mhm.
floating around in the latent space at the time, if you do that willy-nilly, or if you have a team that isn't being careful about how you're tying down the relations to particular semantics and what do they mean, what's the impact on the use case. If you don't go through that process and iterate on it and really understand how to resolve the relations, then you will end up with a graph that's a complete mess and you will end up with a product that fails. And so, I mean, he's been through this a lot of times, working in production, really critical applications with graphs. And their point was you need to have people who understand the relations part of it before any of the engineers get involved. Because if the engineers get involved first, you're going to end up with the kind of mess that you would see if people were just trying to build a graph out of SQL. And so let me illustrate that. The notion of SQL, the notion of relational databases, which is great, again, if you're doing a web app, the notion there is you want to normalize your data. And so there are different columns. The values of the columns are keys that link to some other table. You can do joins across these tables to produce views that are denormalized that then start to become more connected, etc. Assuming that you do not have any data quality problems, that might work in a lot of use cases. But when you're trying to build a graph, in particular, when you're building a graph out of something where data quality is the problem, and in fact, you have, for instance, in fin crime, you have organized networks, criminal activity, where they are trying to obfuscate, they are trying to inject data quality problems into the base data so that you will not be able to build a graph and determine what crimes they're committing. That is the actual game. Then the assumption that, well, my data quality is probably fine and we'll just link based off of whatever is there, that's the kind of thing that's going to make the application fail. And so for really large mission critical use cases, that assumption that your keys, your foreign keys are all going to work out great, don't worry about it. No, you do need to worry about it. And that's the point that Mike Dillinger is making. We'll go into that in a lot more detail. So let's, and I'm going to echo things from a lot of other people too who are in this field talking. I know Amy and I had a great conversation yesterday with our colleague Weidong Yang from Kineviz, and they've been doing work with knowledge maps, kind of a similar idea. The notion of don't bind until later. Get some analysis first and then do your bindings. So what I'm saying is, you've got structured data sources, a lot of them, a typical enterprise, you've got a 4-to-1 ratio between unstructured and structured data. So you've got a lot more unstructured data sources, you've got content. Depending on your organization, they may not even consider content and data to be under the same purview, but they are, and especially these days, working with any kind of AI applications, content is the fuel. So step one, before anybody talks about a database, be able to run some workflows to connect your data together and create views out of it. And once you can find out where you can start to see these connections, well, you'll need to improve them. There's data quality problems in your data. So, sorry, there. I work in an area called entity resolution. And the idea is that across multiple data sets, there are footprints of entities that are stable and they're found to different degrees across different data sets. There you have a name, Bob Smith, but in another data set, he is Bob Smith, and in another data set, he is Robert Smith. And then you have another data set where there's Smith Jr. and Bob Smith Sr., and they both have the same address. So, the thing is, you kind of have the same entity until you find that evidence that shows you, oh, wait a minute, that's not actually the same person. It's like father-son living in the same residence. So entity resolution is a different way, aside from relational technologies. Entity resolution is a way to triangulate a lot of features, more of a machine learning perspective of things, but triangulate on a lot of features to create a kind of overlay, again, semantic overlay, over the top of your data records to say, here are the entities that are stable. These are the relations that seem to be in place between them and between the evidence and the data. And so out of that, you're getting entities, but you're also getting relations among them. And it's a way to understand your data, to make sense of it. So what I'm saying is you can run, big data tooling, whether it's Spark or Snowflake or BigQuery or anything like that. You can be running that to connect together your data, but then peel off, the parts that are going to help you run entity resolution. Find out what entities are across your data that you understand. Find out what is kind of a backbone that connects this data together. And then from there, you can take a view out of that, essentially a subset out of that of the connections, the relations. You can run graph algorithms that measure it, that understand, things like centrality, for instance, is a kind of measure like PageRank, basically, but understand what are the most central elements in the subgraphs within your graph. What are the connected components? You can partition. There's different algorithms get used at scale, like Louvain. But you get that kind of understanding of your underlying data sources once they're linked together. And again, we have not done anything with a database yet. And I can tell you, for very large use cases, they work more on the graph algorithm side of it. That's really the method, but it's also the point, because that's where they get their crucial information. Once you have that level of understanding, you can start to organize. And this gets into what Mike Dillinger was talking about, that Amy referenced. Take some of this processing, shift it left, do it further upstream, but also shift up. Understand more of what your end use case is, how you're going to approach this, how you're going to organize this. And then at this point, now you have more of what you need to begin building out a graph. And at this point, you probably can partition into smaller subgraphs of interest. I can tell you that if a human is involved in analysis, you may have a billion node graph, but that human is not going to use a query that produces a billion nodes in the results. Typically, especially when you're looking at fin crime, when you're looking at marketing optimization, hospitality, over and over, a lot of these use cases that we see, they're doing some kind of partitioning, getting down to a subgraph, and then that analyst or that team of analysts will be working with a much smaller subgraph. And so my contention is, if you want to handle scale, you can use other tools to get you to the point of understanding the graph and how to partition it in ways into essentially subsets that you need, subgraphs that you need. At that point, take the subgraph and put it into a graph database. Something like Kuzu, we use a whole lot. It's really fantastic as an embedded graph database. But at that point, then you can start to manipulate queries and visualizations and all the rest after you've done the other prior analysis. Then you can also start to bring in the products that come out of unstructured or content extraction. You can run entity linking. You can start to do the resolution of relation resolution that Mike Dillinger was talking about and others. And my point being that the running graph queries should be some of the very last thing that you ever do in this process. Having your data engineers and your MLOps people understand the end use case before anybody makes any technology selection or vendor selection, that's also really critical. And so, yeah, as pardon me for being snarky, but I've just seen projects fall apart so many times, but I've also seen some that are very successful. So what I'd say is, as a manager, when you're seeing some of your people really fixate on arguing about technology selection and vendor selection instead of prioritizing how the team understands the use case, your best bet as a manager is to uninvite them from the project, I think is a polite way to put it. But make sure you've got the right people in the room to make those critical decisions up front. And having the wrong people in the room is going to kill your project. Again, I think it's best to have the data engineering people, the MLOps people, et cetera, be able to describe end use case in detail before any product managers or architects get involved. That's another thing. If you don't understand those details, somebody who doesn't understand the technical side of it, they're trying to translate the use case, but they might come out saying, well, most of what we're doing is bulk processing, even though they've heard that there's a lot of streaming, but maybe it's only 20%. But it's the hard 20%. And so they'll come out and they'll relay requirements and they'll say, oh, this is all bulk processing. You can just do this in batch. Make sure that your MLOps people understand the use case before the project managers come in, because otherwise you're going to have a communication problem within your team and have that long before vendor discussions. Again, graph queries should be just about the last thing you'll need to worry about in most of the workflows. Those should come much closer to the end. And so if you watch your team and they're immediately going toward what graph database do we select, what graph queries we're going to be using, if that's their first foot forward, scale is not going to happen. The other thing is that, Amy, any questions on that?
I was just going to say,
the high notes?
Not a, yeah, Yeah, no questions. I just wanted to. I've been taking some notes in the chat, and I'm just gonna hit send here for folks. I was taking out some tips from you. So figure out your biz questions, figure out your data flows, entity resolution, develop your data backbone, shift left and up for pre-processing other tools, then databases,
Yeah.
integrations, then analysis. So I was just quickly trying to summarize some of your nuggets there.
Thank you kindly. That's a great summary. I mean, I think, it makes sense on one hand, if you've grown up thinking just about SQL, that you take all your data and put it into a database, and then you start working with it. Then you worry about data quality. But with graphs, it's a bit trickier, and there's a nuance. To paraphrase our friend Weidong Yang, we were having a discussion yesterday where he came out with this gem. It's like graph data and graph thinking are completely different. Okay, these are two different things. If you fixate on the graph data first without the graph thinking about the use case, you will make the wrong selections. The typical problem is the engineers get all tripped up on like which graph database we use. And meanwhile, they're fixating on that, then the business people come in and say, well, I've heard we have 5 billion nodes in our graph. Does this graph database you selected handle that? And the answer will be no. And so now you're being pushed toward a particular vendor without even understanding your use case. And I see this happen over and over. So the thing is, you probably have a lot more graph data than you could ever fit in a graph database. You may not know that yet, but once you get started on it, that will become apparent. So you're going to have to subset one way or another, subset in a smart way, however process for it. That segues into this one I'll cover kind of quick, but over the past several years, I've definitely seen a lot of discussion about enterprise knowledge graph, and I've been involved on enterprise knowledge graph, and some of the people on the call, I've been involved in that kind of thing with them. I will say that this is an anti-pattern. I have yet to see any case where coming top down and doing enterprise one graph to rule them all from an enterprise level, I've never seen it happen. And I'd argue that in most business units, they're lucky if they can reach alignment about the definitions within their business, even within one domain. And within enterprise, you have many different domains that have to operate. I mean, the people who are in business development have a very different view of the world and very different vocabulary than the people who are in procurement or the people who are in HR. The people who are in operations in Division A use a different vocabulary than the people who are in operations in Division B. And so just trying to get some kind of graph definitions, shared definitions within one domain, that's already hard. Trying to do it across two is really hard. Trying to do it across three, wow. Trying to do it across a dozen or 50, it's not going to happen. So I would also argue that applications do not use enterprise-wide definitions. Instead, applications tend to draw from 2 or 3 domains, but they don't use everything all at once. So, and you probably would not want that to happen for 2 reasons. One is if you use the word customer in front of your VP sales, the metrics involved in that have very different semantics than if you use the word customer in front of a different vice president, say somebody from customer success, solutions. These words take on different meanings and the metrics become different. And aligning that is where a lot of the enterprise knowledge graph kind of projects really trip up. So because the meanings aren't consistent across domains, you want to be careful. And then secondly, if you were actually able to link all of the data in your enterprise together, you've got procurement, sales, operations, all that together. The reality is the security risk would loom so large that no one except for top management would be allowed to even see the results. And this is not hyperbole. I've actually seen this problem arise multiple times. It happens a lot in terms of, we work a lot, I said, in air gap environments, mission critical, highly secure, highly sensitive environments. And there's a real concern that, there's some data that the organization has, and it comes from sources that are highly confidential. We cannot actually let a lot of people within our company even know that this exists. Why? It's not because there's anything wrong. It's just that, like, for instance, if you're in law enforcement, if you get intelligence reports, well, that's useful, but you don't want, the cops out on the street to have intelligence reports about somebody that, may be a foreign agent spy. You just want them to know that if they catch that individual in a traffic stop, they are to be handled specially. You do not want to know all the details because you don't want the information getting out. because there may be some corruption and some of that critical information may leak in places that are really harmful. So this pervasive view enterprise knowledge graph, I think, would fail for multiple reasons. Here are basically three that I'm trying to describe. And
I do have a quick question here for you,
yeah,
and that is the question about the idea of a semantic layer and companies like or organizations like DBT Labs that have like metrics and semantics as a separate layer that you then reference. If that's a better approach, or if we're really just trying to do the same thing by other means and it's doomed to fail as well. What are your thoughts there?
no, I think that's a really good approach. I'm going to reference our friend Zhamak Dagani talking from Next Data. I think a lot of their analysis would align with what you're saying. But the idea is, yes, can you have definitions in those disparate domains within your organization? Can you understand something cohesive within the domain and have that be a kind of closed world? And then understand what are the conduits, like how does one domain interoperate with another? And exactly, yes, I think that having a semantic layer makes a lot more sense if you're trying to basically translate from one domain to another for the benefit of the people in those respective domains. So yeah, I think that kind of tooling is vital.
Okay, thanks.
The other thing, let's talk about, while we're talking about graphs, I will mention later some stuff from Dave McComb, but he has an excellent, he mentions about something that was really guidance for him early on, was this notion of enduring business themes and how it really shapes our thinking. And there's good and bad for that. But I will say that information retrieval has had a long and storied history in terms of data management, and it's a real emphasis on facts. It's a real emphasis on having data management that resembles stacks of punch cards from mainframe days. There's basically a lot of rectangles. Tony Seal has a great talk about this. This is an area where there's search, online marketing kind of dominates a lot of what's going on in search, but this notion of information retrieval is a real dominant idea that emphasizes facts, typically. However, when we're working with graphs, we are actually a lot more interested in relations, and getting the facts wrong is less of a problem than getting the relations wrong downstream, if you're talking about data quality and where the risks are. So, an overemphasis of information retrieval can actually really be a problem when you're working in graphs. And I would say that a lot of what's happened out of RAG in terms of LLM applications based on RAG, those all pretty much came out of information retrieval circles. RAG is essentially reusing some ideas that had come out of, say, recommender systems, but it's a very information retrieval forward kind of idea. As we are working with graphs and seeing how graphs augment, and you get kind of neural symbolic, where you have the best of both worlds. You have some symbolic processing, you have some statistical machine learning. As we do that, then we get ideas coming in maybe more from enterprise data management, where there were strong notions of service mesh, and those have kind of gone into data mesh. There are notions of data catalog and feature store, kind of like what you're talking about, Amy, and there's some legacy notions of master data management, etc. These are two kind of themes, and we're starting to see them collide, and maybe GraphRag is one thing that's sort of at the end of that tunnel. But my question is, do you really need to be doing information retrieval? I mean, seriously, ask yourself, how much do you do information retrieval? I know what I have to do today, and I work very much hands-on with this kind of technology, and I'm very much in the weeds with code, and I'm thinking about how often information retrieval comes. It's important when I need it, but it's a small fraction of what I'm going to be doing today. And I would ask, really, the problem that you have to solve, is it about information retrieval, or is it about something else? I mean, are you struggling with making decisions? Are you struggling with persistent data quality problems? Are you struggling with a lot of fraud? If you're in finance, the latter point is the actual answer. So don't let information retrieval shape your lens too much, the group lens of how you view the world. And the way about this, I'll refer to some other talks that are much better describing this, but start small and work within a specific domain, work within a specific business unit, a specific use case, build out from there. Build out bridges to make use of data products that are coming from other domains, but based on agreements. Like, formalize it, understand why you're using that other team's data and how you interpret it. And when they make changes, what does that mean to you? Iterate on shared definitions. Try to reuse standard vocabularies if it's reasonable to do so, maybe not. But the bottom line is really this. If you want to overcome these anti-patterns, and not do an enterprise knowledge graph, but do something that will actually run in production for a long time. At this stage, to understand across domains, hire librarians, hire editors, hire analytic linguists to understand the communication problems that you have. Do not put engineers in those roles, because I guarantee if you do, the project won't work. And this is again, the people who work at this kind of scale all day, every day know this. So I would say that the people problems in your organization are going to cause a lot more scaling issues in graph practices than any technology concern. And it might be because of security. It probably will be because of some aspect of security. It probably will be because the people making technology selections get involved way too early and buying things way too early. But those are some anti-patterns.
So Paco, before we move to the next section, I do want to just let you know we have about 19 minutes left. So this is nice meaty material, and I want to make sure we also get some interesting questions. So Louis Guy had a couple of interesting questions. I think one may fit before we move on, and that is about, he says he's curious if people are looking into connecting small curated subgraphs across databases, or if you then just rebuild a smaller graph when the new use case comes up. So in other words, do you maintain a France graph separated from a Germany graph and then union them into an EU or European graph, or do you build a European graph from scratch? So subgraphs unioned, or do you try to go with the master graph, which I think fits into maybe some of the things you were just talking about?
Very good question. Hi, Louis. Excellent question. What I would say is, I mean, these are all tooling and patterns that can be used for any particular use cases. Scale, you're going to have to mix and match some patterns, and you're going to have to understand what are the underlying constraints. There may be regulatory, particularly if you're crossing national boundaries and data sharing. There may be other issues in terms of data privacy and security that allow certain data sets to be used in one place but not in another. And so you really have to understand more about the use case, I think, before you could really answer that question. But in general, I would say that in practice, there's a lot more federation kind of patterns where, yeah, you might have something consistent that's a graph that's living over there and it's relatively smaller and it's very much purpose-built for a reason. And then there's other places where parts of it might be used, consumed in a federated way, essentially consumed remotely. I would not have a notion of a master graph. Again, I've never seen that work. Really, it's more a matter of, I think that even some of the people who I really respect hugely in this industry still get tripped up and think that there has to be one graph to rule them all, and it never happens. So I would say that a given firm, I mean, I will pick on friends in a large pharma firm in Europe, where, you know, right now they have 5 large graph practices that are all revenue bearing. And realistically, competitive intelligence is probably the first one that brings back return on investment. But then other things specific to the domain also do. So yeah, definitely think about having more purpose-built ones and then having means of federation among them. I think that's probably a much more robust engineering strategy, as well as like knowledge management. Okay, let me talk about some of the things here real quick, and then we'll go through the latter resources. Basically, not everything should be based on a join. Joins are relatively brittle. Joins are assuming that content doesn't have problems. And I'm going to crawl in a limb and say that joins are just punch cards in disguise. They can be really useful at times, but do not predicate all of your data management on SQL joins. And again, I'll throw back to the fact that I spent a lot of time at Databricks and working with Apache Spark and things like that. Aggregations are interesting, and they're a little bit more robust than, say, a SQL join. I will crawl out on a limb and say that your data modeling talks about entities and relations. Probably your data modeling tools build entity relation diagrams for a reason. And what you really have in your data is entities, relations, properties, probably some probabilities. And let's assume that across all the different data sources that you might want to use, or one data that you might buy, or open data you might bring in, let's just assume that there are some entities, some relations, some properties waiting to be identified. And by the way, those are elements of building graphs. So let's look at the world this way, just for a moment. Suspend your disbelief. I love this quote from Abhishek Nagaraj. Think of data as an imperfect map of the underlying entities. Collections of data sets will have entities, relations, properties. Finding those non-obvious connections is really the challenge. And it doesn't have to be done by running SQL joins. There are other ways to handle this, probably arguably better. I work in an area, entity resolution. We do not look at matching records to records. Instead, we look at triangulating on different features from the records to find out where can we come up with enough evidence to support a decision to merge or disambiguate in different entities. And we do that across a lot of like 80 different globalization contexts. So, the idea is one data set has Abdullah Kardash in Arabic. His name is there, but there's another database that has Alhaj A. Kardash bin Amir. It's the same person. It's represented culturally in very different ways. Another data set has his name translated into Italian. Trying to do fuzzy string matches on this will break. So trying to do, any sort of join on this will break. What you need to understand are the cultural implications within your data and leverage those cultural norms to be able to, again, triangulate on the features and understand, here's how we handle nicknames in Russian, here's how we handle nicknames in Mandarin, here's how we handle nicknames in Arabic, things like that. I'm going to link to entity-centric learning from Senzing to describe more about this. I have other talks that also go into detail. But the idea is that as you're running this, you're generating entities, relations, and properties, and these are elements for building graphs. It creates a kind of structured backbone for your graph based off of your structured data. And from there, you can layer in other things that come from, say, unstructured sources. And there are two design patterns to really be concerned with. One is more of an ETL initial population of entity resolution, typically with bulk processing. So you peel off PII features as you're doing ETL, you run it through entity resolution, and you create a kind of backbone for organizing your graph. There's a second design pattern, and we see both of these typically implemented together. The second design pattern is the harder problem is updates, because you're not always doing ETL. Instead, you're going to iterate on small subsets, deltas, or maybe some domain expert has important feedback in the graph. And this is where you're going to take whatever has been updated, run it back through entity resolution, find out if there's new evidence to support a merge or disambiguation of your overlay, your semantic overlay, such that the entities and the relations are changing. And we do this very low latency, down to milliseconds if needed, but it's basically record by record streaming. So these two design patterns are what we typically see leveraged. It's important to have both. Yeah, this is a way of creating a view of creating a backbone for a graph. I'm going to move forward and just say that there's another kind of design pattern that we see a lot in fin crime, but it also gets used in customer 360 and marketing and like patient 360 and healthcare. The idea is this: build your graph, get it connected together. Like I said before, you can use a lot of tools for big data management, Spark, for instance. Use entity resolution, figure out what is connected, how you can pull it together, use graph algorithms to find out more about the structure of that data. From the graph algorithms, you can partition into subgraphs. You can have the entities of interest be ranked higher, for instance, by using, and that allows you to take and split that very large graph from many sources into smaller subgraphs. Typically, if you're in a bank, these will be run through case management tools so that, a level A financial crime analyst will be looking at a subgraph of 20 nodes instead of a billion. So the reason you use entity resolution that I'm showing, here's a case from Panama Papers, Abasim Badshaw, about £1 million of tax evasion in London. And if you just take the data, it's kind of connected, but once you pull it together with entity resolution and graph algorithms, you start to see the central player who owns and controls shell companies bubbles up to the top. You should probably start your investigation there. So this four-step design pattern gets used a lot throughout different fin crime, but it's also used in marketing. And I think that that's a general kind of pattern to use for really thinking about the last question of how do we handle scale? Because at the end of the day, this is what your use case is going to be doing for a lot of use cases. And the same things that get used for crime can also be used for, tourism and hospitality, for finding out you're doing householding to find out who your best customers are. So I'm going to scoot ahead real quick. We work in an area where there's a lot of bad guy hunting, public sector, tax evasion, counterterrorism, fin crime, also investigative journalism, OSNT. A lot of it is in finance. And these are kinds of applications we see: a lot of KYC, AML, a lot of risk mitigation, anti-fraud. But there's also, repairing and enhancing data. And I think like EY's work, on traditional information systems to reduce fragmentation and the impact that has on people who are moving through the court system, like people who, might have not been told about their court date and now suddenly they're going to jail for something they didn't even know about. Patient 360, legal e-discovery in law enforcement, etc. These are kind of more of the enhancing and repair data use cases. And now for a twist. I know I want to get to questions, but I want to say a few things real quick. Here's some homework. Dave McComb had a talk recently with Larry Swanson, who I think is on the call. Really brilliant talk, 25 years experience in their team, even before RDF was around to use. He talks about how to start smaller and be successful in enterprise applications of graphs. He talks about building toward enduring business themes and data-centric enterprise systems. Jamak Dagani, excellent insights. This is a retrospective piece. Really, she's talking about how to nurture communication and trust and accord agreement alignment across domains, thinking about it in terms of contracts, and think about it in terms of domain-driven architecture, but the impact that has on data management. Another one, really brilliant, very short, just a few minutes, especially the last half of this 5-minute video. It's from Tony Seal, and he talks about how to start thinking in terms of graphs, networks, and probabilistic processes, how to get away from industrial thinking, which forces data management into a rectangular box shape. Jessica Talisman, really great. This could become a book, and maybe it will. But excellent piece here on Modern Data 101 about leveraging an ontology pipeline, working with vocabularies, thesauruses, taxonomies, etc., and the role of library science in forming preparation for AI. Mike Dillinger, here's the one we were talking about. It's an interview we had last week, talking about relation resolution and entity resolution together, his experiences at LinkedIn, etc. Me, I wrote a book a few years ago called 50 Years of Data Management, and it kind of looks at each decade, the big ideas that have shaped the frameworks, that have shaped the thinking, and how those change every decade. And also my friend, Jürgen Mueller, my good friend, we worked for several years on some very large enterprise problems. We have a series of articles called Sense and Scalability and also Graph Thinking to really, how do you approach the business problems at hand, leveraging graph technology, how to consider the human thinking that will be involved and be augmented by AI applications. And finally, I think probably the one you start with is Ted Chiang. He's a science fiction author. Great interview in LA Review of Books by Julian Crockett. How to consider approaching problems without rushing into engineering solutions in advance. And he makes the point that in French you would call this a professional deformity, thinking about everything as an engineering problem. It's probably good to start here. I know we have questions. I have a bunch of calendar through the end of the year, but definitely Knowledge Graph Conference. Well, Graph the Planet comes up next week. Knowledge Graph Conference early May. Really looking forward to that in New York City. Data-Centric Architecture Forum is one of my favorites. It'll be in early June. This is Dave McComb's team at Semantic Arts. Semantic Layer Symposium will be in Copenhagen in early October. My friends at Enterprise Knowledge. Really looking forward to that. And MLOps World Summit. I mentioned this because it's kind of a big tent, and all the right people are there. The product managers, the data engineers, the ops people, AI engineers, etc., and really focus on the real world experiences of practitioners. But this is where I learned more about graphs than anywhere else, probably. And Connected Data London is scheduled for November 20th, and we're really looking forward to that. And I will head to QA. If you want to get a hold of me here, we'll have the slides.
So I'm going to open up talk, so your mics are going to go live. But as we're doing that, I'm also going to start a poll, because as Paco was talking about all this homework, I thought, how am I ever going to get my homework done? So if we're interested in doing this together, why not? We have Ask Me Anythings with Paco about once a month-ish. So we could always use that for homework follow-up too, which would be fun. So I have a question. I'm not seeing new ones coming in the chat. I think we got to most of them. But one of the things that I'm curious about your take on is that I often talk to people about use cases not arranged by necessarily whether you're trying to find criminals or doing patient journey. I often kind of avoid that because there's usually so many different tasks involved, to your point about there's pre-processing, there's analytics, it's very iterative. I often talk to them about three, and maybe there's more workload use cases, which are around exploring and I have three that I talked about. Exploring and investigating the graph, deep path analysis, and patterns and anomaly detection. And I feel like I can put almost every graph use case in one of those three major buckets, and that will tell me whether I need very fast ad hoc querying or whether I need good global graph algorithms. Like they shift. What are your thoughts about that? And are there other big buckets we should be thinking about?
I mean, the pathing, yeah, pathing is one of the key arguments for, say, using a labeled property graph. Pathing and visualization are two really key arguments for using a labeled property graph rather than using, say, RDF. Whereas, like, validation is a really good argument. Validation and inference are really good arguments for using RDF instead of labeled property graph. You can handle a lot of pathing. In fact, I would argue that it's probably easier to handle a lot of the pathing earlier using graph algorithmic approaches, using graph analytics prior to getting into the realm of doing query. So if you need to be understanding some of the shape and dimensionality, how wide is my graph? How long are these paths? Are there some paths that are really long that are going to be problematic later on, and maybe we can take and partition the data in smart ways to handle for that? I would argue actually do that more up front. Don't wait until you're starting to do graph queries to understand that part of your graph. You're right. There's a lot of exploratory, iterative kind of approach. I would say that the nature of data science and graph data science in particular is more about investigation than it is about prediction. And so there's always an iterative nature because you're always getting updates. You're going to find out things. You're going to bring in more data sources. They'll clarify. You're always going to be iterating. That is a problem. How do you handle the updates?
Yeah.
And long and short, though, is you want to start out with some pretty good, falling back again to something that Mike said last week, you want to start out with some good definitions and you want to keep them until you can find evidence for why they need to be updated and changed. So find out your structure first.
Yeah. Okay. And we have just a minute left. And Larry, you've got your hand up. I hope your mic is live. Can you go ahead and ask your question? Yeah, we've got you.
Hi, Larry.
Yes. Hey, Paco, how's it going? A restaurant in Leiden last week called Paco Chow. So if you're ever in Leiden,
I want some. I want some kibble.
No, but hey, I wanted to ask real quickly. I'm transitioning next week out of the content world into a really cool job with a semantic vendor that you'll all know. But I feel like I'm not abandoning my content people. You mentioned content a couple of times, and you also talked about like hiring librarians and content people and things like that. Can you have examples or advice for people who are content people are struggling a lot right now? And I would love to point them this way, but how do I guide them in?
Yeah, I mean, it's really ironic that at a point when, we have these systems that basically use content for fuel, the enterprise decision makers don't understand that. This is really probably some of the most valuable asset that you have in your company. Right. So yeah, mining your PDFs, but also other things too. It's not just all PDFs. There's probably some videos and you probably get some pretty good mileage out of that too. How do we fix it? Well, I'm presenting a counterpoint to a lot of sort of the dominant vendor narratives, which would say put all your data in a graph database first and then worry about the problems downstream. So I don't know how to solve this problem in enterprise. I have seen it resolved in particular projects that do well, that have some strong leadership. And again, I'll probably defer. I think you also had an excellent interview with Jessica recently, Jessica Talisman.
Yeah, well, Jessica I was thinking about for sure. Yeah.
And Jessica is in a really interesting role because she's at, wait for it, Adobe. And what does Adobe do? PDFs. And what is it we're all struggling with? PDFs. So yeah, she has some pretty interesting perspectives on what if you actually had a whole bunch of content, what would you do? And I think that I'm leaning on her for guidance on this because I will go back to it. I really do think that people who have training more in these kinds of fields, library science, are going to be making better decisions about structure and projects. And, some of the conferences that I just mentioned, some of the consultancies are, I can think of one in particular that is led by somebody who is, former librarian. I don't know how to answer that question per se, except that
the thing that prompted the question was that talk with Mike when he mentioned the poor traumatized engineers at LinkedIn, stuff, and content people are really good at that. So that seemed to me like one possible way in. Yeah.
Well, I think it is. I mean, I think that if you want to be a leader who's really effective and has these projects enduring, working, I think that that's part of the trick is like bring in the folks from the content side who understand about what's going to get used in the end use case. Bring them in early and get them in front before all the engineers have carved it up and come out with a Gantt chart that describes the project timelines and all the vendor selections. Get that part of the use case represented first up front, and particularly get your operations people to understand what they know So I think if you have your MLOps people and your content experts together, they can probably make a lot more progress than if you take a software engineering first approach.
Cool. Thanks so much.
Thank you, Paco. Unfortunately, we've run out of time, so we will have to leave it here for today. But looking forward to the next time we chat and diving into some of these different areas. Thanks for all the homework. For those interested in working on homework together, let us know. Get on GraphGeeks Discord and maybe we can spin something up that would be fun in that. So
can we take more questions to GraphGeeks Discord also?
Absolutely, yeah. If you guys have more questions, you can just roll over to the Discord, and Paco and myself are on there quite a bit, so we can always follow up there. So thank you again, everybody. Thank you, Paco, and have a wonderful rest of the day.
Thank you, Amy.